Hello everyone, my name is Zia. I am a data scientist and I have been working in the domain of data for past 8 years. Today, I'll be explaining to you guys how we can measure the geographic bias by using massive proxies. Not only that, we have a very interesting use case because sometimes being a data scientist, data analyst, or anyone who is working with the data, you need to know how this data looks from some other how it looks from some other geographical location. For example, I am sitting in United Arab Emirates and I want to see how my data or how any particular website would look like from United States. Well, I have to travel over there in order to learn that how it looks like, what data it is showing to me over here versus what data it is showing to someone who is sitting in the US. Well, if this is your use case or your use case is somewhere closer to this one, we've got you covered. What are we going to do in this tutorial? We are going to test these massive proxies on three different queries. First query is going to be what is blockchain, and then we have by second query is by cloud hosting, and the third one is best restaurants. So we know that if I search for the best restaurants, here it'll be different versus in US it'll be completely different, right? So we'll see how much bias is there. So we'll be measuring that bias, that geographical bias, in today's tutorial. You can also find the link to a detailed article in the description where you can find the in-depth explanation as well. Right now in this tutorial, I'm going to explain how you can practically implement it by using massive proxies on Python and how you can actually make it work in less than 15 minutes. So let's get started. All right, so we are going to use DuckDuckGo for this tutorial. And let's say here I search what is blockchain, which is part of our query set. If I search, I'll get some links. And that is what we are going to test on different proxies that we are using for different cities. So let's go ahead. And here we are importing some libraries. Very quickly, we are using time just to know how much time is needed or spent on a particular iteration. We are using random. We are using requests to get the data. We are using pandas in order to process the data. We are using TQDM in order to get that progress bar. We are importing list, dictionary, beautiful soap. We all know that important for data parsing. Oh, sorry. Yeah, beautiful soap for data parsing and some more URL libraries, again, for the parsing purposes. Now, we have three queries. As we know that what is a blockchain? By cloud hosting and best restaurants, right? So we are going to search these three queries from these many cities. So we are going to use New York, we're going to use Los Angeles, we're going to use Chicago, Houston, and so on and so forth until San Jose, right? And after that, what we're going to do is we're going to say city in the query equals to true. These are a few parameters that will be used later on, but the important parameter is here that says use proxy. So if this use proxy will be true, it will be using the proxy as name suggests. If it will be false, then it will not be using the proxy. Username, you have to provide your own username and password. I have already provided these username and password over here in this cell, which is hidden. So that's why I'm just using some variables over here, right? Then we are hitting the host of join massive, and then simply some setting some headers. And now I'm fast forwardly going to the main function, and then from main function we'll track back that which function we are calling and where we are calling it, right? So here main is starting. So first of all, we are just setting some Python parameters, not very necessary. If you don't set it, that's totally fine. Now the important thing is we are getting the proxies, right? So where's the get proxy method? If we search it, here it is. So we are simply checking if use proxy is true. Remember this use proxy parameter. If this is true, which is true, then sorry, if this is not true, you can see not over here. So if this is not true, then none. Otherwise, return this whole proxy object which is being created by using proxy username, proxy password, host name, and proxy port, right? Very simple. Then what we are going to do is we are simply creating a data structure in which we can store our results that you might have seen in our article as well. The results are being displayed in such a beautiful tabular manners that it is easier to understand which correlation is there between two cities. Then we are here, the actual game starts. Here is the heart of this whole algorithm, right? So we're iterating over all the queries, right? By the way, this TQDM will be only used for the progress bar. Let me show you over here. So this kind of a progress bar, okay? So this TQDM is for that progress bar, and then we are iterating over all the queries. We have 3 queries. We know that. Then for each query and for each city, we are gonna hit this DuckDuckGo URL once, right? Since we need the results for all the queries and all the URLs. So here we are saying, first of all, the query city is going to be this much. This is going to be the query city. And we are saying fetch URLs, right? Now, what is this fetch URL? And by the way, we are passing the query city, the proxies, and we're also saying fetch k. What is fetch k? Let's first search what is fetch k. So fetch k actually tells us how many number of URLs do we want to fetch. And then we also have this keep k variable that tells us how many unique URLs, how many top unique URLs we want to keep. We'll come to this in a minute. So what we are doing, we are going to fetch URL. Here it is, fetch URL, right? So here inside this, we are trying 2 loops, right? One is for DuckDuckGo HTML URL, and another loop is for DuckDuckGo light URL. In case if DuckDuckGo HTML URL is not supporting or down, we will get results from the light one as well. So here we are saying go ahead for these number of retries which are mentioned in the beginning, if you remember, and then we are saying we will get R1 over here. So we are fetching DuckDuckGo URL from the by using these proxies, and then we are parsing it. Okay, how are we fetching it? Let's see. So here is the fetch method. So we are simply hitting this URL by using this request method. So we are saying request.get using these headers, hit this URL using these proxies. This is your timeout, and let's go and return this object. So whatever object we will get, we'll check its status, and then we'll say parse it. So whenever we get the URL, the first thing we do is we parse it. So let's see how we are parsing it. So here, very simple. If we go to this DuckDuckGo, we inspect this page, we can easily get the classes that we want to get, right? So we are going into dev, then results, then dev.web results, and then we are fetching all the anchor signs, and we are continuing it. Simple data parsing logic we are using over here. And same is happening over here, only the class names or the links are slightly different, or CSS selectors might be slightly different. Otherwise, it is exactly same for DuckDuckGo Lite as well. So this whole loop will run for retries number of times, and then ultimately it will return all the URLs that it will get. Remember, all the URLs. And then let's go to the main. So now fetch URLs thing is done. So let's go to the main loop. What is happening then? Then once we have all the URLs, then we are saying keep top unique domains. So we don't want to, I mean, whenever you search something, it is quite possible you get multiple links from the same domain. So we don't want to keep, we don't want to repeat the domain. So we want to make them unique, and then we want to keep n number of or k number of domains. So here, how many unique URLs do we want to keep? Keep k, which was 10 if you remember, right? So let's quickly have a look into this code as well. So simply we are finding the unique ones, and then we are getting the top ones, right? And then we are throwing the whole result into all the domains into the result data structure that we created in a manner that for each query and city, these domains will be stored separately, right? So until here, we have all the domains ready and sorted in our results parameter or results variable or results data structure. And then here we are going to calculate the AP correlation as it is clearly mentioned and explained in the article as well. This is approximate precision correlation matrices where in short, let's not go into technical details. In short, if it is 1 between two cities, if the value is 1, it means that all the URLs were same. But if it is 0, it means all the URLs were different. If it is in between, so you can understand how much deviation was there, right? So we have the results over here, and then we are simply putting those results into these matrices. We are appending it up, and then we are showing it as a data frame over here, right? And this is how it looks like. For example, for first query, the AP correlation matrix for what is blockchain is this much. For by cloud hosting, it is this one. And for best restaurants, it is this one, right? It was expected that there will be a lot of deviation. There will be a lot of deviation in best restaurants. Why? Because obviously restaurants are different in your city versus my city. But the what is blockchain? The definition of blockchain might be same, but not guaranteed. It can be different. It is quite possible that in different regions, different websites have different optimizations so that their results they may vary in certain regions. So if we talk about what is blockchain, between New York and New York, it is 1, obviously. They're the same data set. So between the same cities, the same data sets, the correlation is always going to be 1, as you can see over here as well. Between LA and LA, it is going to be 1. But between Chicago and LA, it is going to be 0. Well, between Houston and LA, it is going to be 50%, so which means that 50% of the links, of the top unique links, were same and 50% of them were different. And if we go for by cloud hosting, you can see it is same for Phoenix and LA, and it is roughly 75% same and 25% different between Houston and LA. Moving on, if we talk about the best restaurants, it is for Houston and Houston. It is 1, which means same cities. It is exactly same. But let's find some different ones. So for example, for Phoenix and Chicago, there is 67% similarity in the links. And by the way, these links they might not be exactly for the restaurants. Let's quickly search this thing. They might be for the blogs that will recommend you the restaurants. So here you see the words 50 best restaurants. So these might be the blogs. Here is by the TripAdvisor. So if it is 1, as you see between Houston and Philadelphia, it is 1. You might say, hey, in Houston and Philadelphia, the best restaurants cannot be same. You're right, but the links, the recommending websites, the blogs, they might be the same, right? I hope that makes sense, and that makes it pretty much clear that if you want to search for a particular thing by sitting at a location A, but you want to look at that thing from the perspective or from the lens of location B, very simple. All you have to do is you have to set up a proxy like this, and you're good to go. So I hope these things make sense. I repeat, I used join massive APIs for join massive proxies. Join massive proxies for this whole process, for this article, for this tutorial. That worked perfectly fine for me, and I would really suggest you to use that at your end as well.